Let's take a look at how to simplify square roots. A square root is not considered to be in simplest form if it has any perfect square factors. To simplify a square root, factor the expression under the radical into perfect squares. Then apply the root of a product rule. Here we have the square root of 18. If the number under the radical has any perfect square factors, this is not considered to be in simplest form. We need to figure out what perfect square factors are. It comes from two different pieces, perfect squares and factors. We can find the perfect square factors of 18 in one of two methods. We could either start by listing the perfect squares, or we could start by listing the factors of 18. Perfect squares are numbers whose square root gives you an integer. You can find the perfect squares by simply squaring each of the counting numbers. We can start by squaring 1. 1 squared is 1, so 1 is a perfect square. 2 squared is 4, so 4 is a perfect squared. 3 squared is 9, 4 squared is 16, and here we can see we've listed enough of the perfect squares that are going to get us close enough to 18 that we'll be able to find the biggest perfect square factor of 18. Notice it takes two requirements. We need both a perfect square and a factor of 18. Here we've only listed the perfect squares. We want to find the largest perfect square factor of 18 possible. 16 is not a factor of 18. 9, however, is a factor of 18. So I want to factor 18 into 9 times 2. Now, from here we could continue, but first I want to show you how we could have done this in an alternative way. We can do this by listing the factors of 18. Remember that factors of 18 are simply numbers that can be used to multiply together to give you 18. To begin listing factors, you should always start with 1 and the number itself. 1 and 18 are factors of 18. Then list whether or not 2 is a factor. You can easily tell if 2 is a factor of a number because if the number is even, 2 will be a factor. 18 is even, so 2 is a factor. Now we need to figure out what number we can multiply 2 by to get 18. That number is 9. Check to see if 3 is a factor of 18. It is. So we can multiply 3 by 6 to get 18. Check 4. 4 is not a factor of 18. Check 5. 5 is also not. We've now arrived at 6, which already is a factor of 18, so we know that we're finished. These are the factors of 18. Similarly with what we did with the perfect squares, we want to start from the biggest number and ask ourselves, does it meet the other requirement? Here we came at this from the perspective of starting with factors and then finding any perfect squares. We've already listed the factors. Now we need to check to see if each of these is a perfect square, starting with the largest. 18 is not a perfect square because the square root of 18 does not give us an integer. However, 9 is a perfect square because the square root of 9 gives us 3, and 3 is an integer. You can see that regardless of which process I used, I will get the same number, 9. So I can use this rule. To simplify a square root, factor the expression under the radical into perfect squares. Well, here's the expression under the radical, and I know I can factor this so that it has a perfect square factor of 9. I don't want to change the value. So that means I need to figure out what I need to multiply 9 by to give me 18. That number is 2. This tells me that 9 times 2, the square root of 9 times 2, is the same as the square root of 18. Because I factor this into a perfect square, this will allow me to simplify this expression. This tells me now to apply the root of a product rule. Remember that the root of a product rule states that the root of a product is the product of the root. Should say roots. The root of a product is the product of the roots. This is a root, and inside the root is a product, so this gives me the root of a product. The root of a product is the product of the roots, which means that I can write this as a product of two different roots, meaning two roots being multiplied by each other. I need to take the same factors that were inside the root, so this will be the square root of 9 times the square root of 2. Because 9 is a perfect square, I can simplify it. This becomes 3 times the square root of 2. This is considered to be in simplest form because 2 no longer has any perfect square factors. All of the perfect square factors have been taken out of the square root using the rules of square roots that we have. Therefore, the square root of 18 simplifies to 3 times the square root of 2. If you have a calculator, you can confirm this by typing in the square root of 18 and finding out what the decimal is. You should get the same thing as when you type 3 times the square root of 2 into your calculator. These two expressions are equivalent. Let's take another example. Let's say we want to simplify the square root of 50. Here we can either list the perfect squares or the factors of 50. I'm going to choose to list the perfect squares. Either method will work. Remember, we can generate perfect squares by squaring each of the counting numbers. We take 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Now you actually only have to go up to half of the number inside the square root. If you forget that, you can actually keep going. It'll never hurt to list more perfect squares than you actually need to. It'll just save you some time if you know exactly when you can stop. Now you know once you get to 1 or 2 less than the number inside the square root, you're pretty safe to stop. Not only do we want perfect squares, we want perfect square factors of 50. 49 is not a factor of 50, and you can check to see if numbers are factors by plugging them into your calculator. Take 50 and divide it by 49. You'll notice that you get a decimal result. It's not a perfect square, it's not an integer, so 49 does not go into 50. Similarly, 36 is not a factor of 50. However, 25 is. You can tell by typing 50 divided by 25 into your calculator, or just knowing off the top of your head that 50 divided by 25 is 2. 25 goes into 50 evenly, so it's a factor. We also have already confirmed that it's a perfect square, so to simplify, we write the square root of, we want to have a perfect square factor, 25, but we don't want to change the value, so we need to multiply 25 by something that'll give us 50. That's 2. Next, I use the product rule. This says the root of a product is the product of the roots. So I can rewrite this as the square root of 25 times the square root of 2. The square root of 25 is 5, and I don't know what the square root of 2 is, or rather the square root of 2 is not a perfect square. Since there are no perfect square factors of 2, this is now in simplest form. This is 5 times the square root of 2.